The next method of solving a quadratic algebraically is solving by something called the quadratic formula. So, quadratic formula, the first thing that we need to do is just review standard form, which I have written right here. So, standard form is y equals ax squared plus bx plus c. So, it's written in the degree order from the highest degree to the lowest degree, ending with a constant. So you definitely want to put your quadratic in standard form before using the quadratic formula, okay? So the quadratic formula is a bit daunting, but there is a song that will help you learn it, and that's how I know it to this day. So I will be attaching that link on my calendar, and I will be putting it on Google Classroom, and as silly as it is, it's the best way to learn the quadratic formula. So it goes x equals negative b, and then you have plus or minus the square root of b squared minus 4ac, and the whole thing you divide by 2a. So a lot of people actually, as confusing as it looks, like this because it works every time, okay? So factoring won't work every time, but quadratic formula will work every time, and you really are just plugging in numbers. So the biggest thing is just making sure you don't make a mistake along the way. Okay, so our first example, we have 3x squared plus 7x plus 2, and it is in standard form, so we're good to go. So I like to identify my A, which is 3, my B, which is 7, and my C is 2. And I'm getting that from the fact that standard form is ax squared plus bx plus c. Okay, now I'm going to plug it in using the formula. So x equals negative b, so b is 7, so it will become negative 7 plus or minus the square root of b squared, so 7 squared, minus 4, and then we have a and c. So this first time I'm kind of writing it out more than I normally would, just so we can kind of see what's happening. And we divide this whole thing by 2 times a, and a is 3. So we keep going. X equals negative 7 plus or minus the square root of 7 squared, which is 49. So a lot of people want to say, oh, well, we know the square root of 49 is 7, but it's 49 minus that entire thing that we're taking the square root of. So minus 4 times 6, because 3 times 2 is 6, and this is all over 6. So then we get x equals negative 7 plus or minus the square root of 49 minus 24, because 4 times 6 is 24, all over 6. And then next up is to combine those like terms. So negative 7 plus or minus the square root of 49 minus 24 is 25. Divide by 6. And then this turns into plus or minus 5, because that's what the square root of 25 is. So this is where we end up. And what we do, because we can combine all these numbers, I like to split it in two. So we have x equals negative 7 plus 5 over 6. And we also have negative 7 minus 5 over 6. So negative 7 plus 5 would be negative 2 over 6, but that simplifies to negative 1 over 3. So that is one of your answers. The other one is going to be negative 12 over 6, which simplifies to negative 2. So those are your two x-intercepts, which means the graph crosses through the x-axis at negative 2 and negative 1/3. Okay, let's go ahead and try another one. I know it's a long process, but as long as you just kind of check your work as you go, it's not too hard. It's just tedious. So the next problem, we have 2x squared plus 7 equals 8x. So the reason when I go back to the top of this notes and I said put in standard form before using the quadratic formula. So a lot of students would look at this and they would say A equals 2, B equals 7, C equals 8, okay? Well, it has nothing to do with, oh, this number's first, this number's second. It has to do with standard form, which is the highest degree to the lowest degree. So the first thing I actually want to do is move over the 8x to the other side. And when I do that, I subtract it and it needs to go in the middle because you always want to end with the constant. Okay, now it's equal to 0. And then identify my A equals 2, B equals -8, and C equals 7. So now I'm ready to begin. So x equals -b. So again, I'm plugging it in the formula. Well, b is already -8. So if it's -8, it's going to be +8. Then we have the plus or minus the square root b squared. So that would be -8 squared, which is 64 minus 4. So this time I'm going to kind of combine things as I go. So then it's -4, and then you multiply A and C. So A is 2 and C is 7, so that would be 14. And this is all over 2 times A, so 2 times 2. So we keep going. X equals 8 plus or minus the square root of 64 minus. So 4 times 14 is 56. And this is all over 2 times 2, which is 4. Then we get x equals 8 plus or minus the square root of 64 minus 56, which is 8, all over 4. Okay, so the next step, obviously we can't add those like they are because we have a square root and we have a number that's not a perfect square. So I'm going to go ahead and branch 8 so we could see what that would be. So we have 2, 4, and 2, 2. So I have a pair of 2s and a lonely 2. So now we end up with something like 8 plus or minus 2 root 2 over 4. Okay? So looking at this, when you look at these 3 numbers right here, if there is a common factor or a number that you can take out, then you would do that. Now, if it was just, let's say, the 8 and the 2 and not the 4, then we couldn't really do that. So it needs to be all 3 numbers, okay? The other thing is, whatever's in the radical, that is not a like term. So we can't reduce that. That is set. So all 3 of these numbers have 2 in common. So if I do 8 divided by 2, I get 4. If I do 2 divided by 2, I get 1. Well, I don't really need to say 1 root 2. I could just say root 2. And 4 divided by 2 is 2. So this could be our final answer. So there's actually, we can simplify it further if we want, just so you know. We could also write this as 4 over 2 plus or minus 2 or root 2 over 2. And then 4 over 2 is 2. So it's 2 plus or minus root 2 over 2. So for those of you who want to go the extra step, but I would totally accept what I have in the box, okay? So we're going to go ahead and do one last problem. So this one we have 2x equals x squared minus 4. So again, A is not 2, and B is not 1, and C is not -4. So in this, we actually want to put it in standard form. So x squared goes first. I want to subtract the 2x to the other side. That goes in the middle, and then I have -4. Now I identify my A, B, and C. Since there's no coefficient in front of x, we assume that it's 1. B would be -2, and C would be -4. All right, now we plug it in the formula. So x equals -b. Well, b is -2, so it would be +2 plus or minus the square root of b squared. -2 squared is 4 Then it's minus 4, and then you do a times c. So a is 1, c is negative 4. When you multiply them together, you get negative 4. And this is all over 2 times a, which is 1. So then we get x equals 2 plus or minus the square root of 4. And then we have minus 4 times negative 4. So let's think about that. Negative 4 times negative 4 is positive 16. What we don't want to do is a lot of students want to say, okay, 4 minus 4 is 0, and 0 times negative 4 is 0. But that's not what we're doing. We're doing 4 minus the quantity of 4 times negative 4. Okay, so then this all is divided by 2, because 2 times 1 is 2. So we get x equals 2 plus or minus the square root of 20 over 2. Then we want to look at 20, and we can branch it. So 2 and 10 and 2 and 5. So I have a pair of 2's and a lonely 5. So I get x equals 2 plus or minus 2 root 5 over 2. Looking at all three of those numbers, I have a 2 in common, so I could divide by 2, and I would get 1 plus or minus. Now again, I don't really need the 1 root 5. I can put it there, but it's not necessary. And I definitely don't want to say divided by 1, because we know anything divided by 1 is just itself. So this is the quadratic formula. It's like I said, tedious, but not too difficult, but it definitely takes practice.